So in this video, we're going to do an integration by parts problem where we only need to apply integration by parts a single time. So this is going to be like the simplest possible scenario that we can find ourselves in. So the directions here say integrate 1/2 x squared ln of x. And here's the integration by parts formula that we developed in video 1. So we're being asked to integrate this mess right here. And here the 1/2 is a constant term, so we know that we can factor it out front. So we get 1/2 the integral of x squared times the ln of x dx. And what we want to identify is that this particular integral is not one that we've had to deal with yet up to this point. So we don't have anything in our pocket that just allows us to integrate it immediately. So we want to try to use the integration by parts formula. And the way that the integration by parts formula works is we let one of these two functions, we have a product of two functions, we have x squared and ln of x, we let one of these two functions be represented by u, and we represent the other function with v prime, the derivative of v. And it doesn't matter which one is u and which one is v, as long as the right-hand side of the formula works out for us. So I'll show you what I mean by that. So let's suppose that we decide we're going to let u correspond to x squared because x squared comes first and the u comes first. And what we'll see is that this is going to lead us to a dead end. So if we let u equal x squared, that means that v prime, the derivative of v, is going to have to represent, if we let x squared be u, then v prime is going to be the ln of x. So we would say, hey, v prime is the natural log of x. And the integration by parts formula says, hey, you can integrate the stuff on the left if you can do this over here. And in particular, what we want to find is an integral that we can actually integrate showing up on the right-hand side. So it's going to be equals, and it's going to be the 1/2 times the stuff in the integration by parts formula on the right-hand side. So to do the right-hand side of this formula, we need to know a couple things. We need to know what v is. We know v prime is being represented by the natural log of x. We need to know what v is. And we also need to know what u prime is. Here we're letting u be x squared, so we would need to know x prime, or sorry, u prime. Well, u prime we know. The derivative of x squared is just 2x. And then v prime, to get v, we would have to integrate v prime, integrate the derivative to get the original function back. So we would need to integrate the natural log of x dx. And the issue here is, if I recall correctly, we haven't integrated the natural log of x yet. This isn't something that I think we've had to do. So we wouldn't know how to get this integral. If we did, we might see that we might find out that the integral actually leads us in a circular path and doesn't maybe get us where we need to be. So that would be a dead end. So if that doesn't work, all you do is say, hey, I'm going to change. I have a product of two functions. I don't know how to integrate it. I'm seeing if the integration by parts formula will help me. It may or may not. But we'll just change which is u and which is v, right? Order of multiplication doesn't matter, so it's just as easy to say v prime u as it is u times v prime. So we'll let the natural log be u. So if the natural log is u, we get this. And then that's going to make x squared play the role of v prime. So here's the v prime sitting here. So v prime is going to be x squared. So v would have to be the antiderivative of v prime, or the antiderivative of x squared. And we do know how to take the antiderivative of x squared. That's just 1/3 x cubed. And then right here, u prime would have to be the derivative of the natural log function, but we also know that derivative. The derivative of the natural log is just 1/x. And we're able to find all four of the pieces, so we just plug those four pieces in to the formula we have up here. So the formula says that this antiderivative on the left that we're interested in can be found by taking u times v, which is just the product of these two terms, u times v. So that's just going to be 1/3 x cubed times the natural log of x, 1/3 x cubed times the natural log of x gives us the product of u and v. and then it says subtract the antiderivative of u prime, and u prime is right here. Take u prime and multiply it by v. Take u prime times v. So u prime is 1 over x, and v is 1/3, so 1/3 x cubed, and we need to take the antiderivative of that. So it's 1/3 x cubed, and we need our dx. So equals, and then I'm going to go ahead and erase this to give myself some room. So I'm erasing it slowly to give you a chance to pause the video and write it down if you have to. So now I'm going to get that out of my hair. And I can do some simplifying over here on the right hand side. I get 1/3 x cubed times the natural log of x minus this 1/3 is a constant and will factor out in front of the integral sign. And x cubed divided by x will be x squared dx, as long as x is not equal to 0. So we would have to stipulate that, but we shouldn't be in trouble there, because the domain of the function we're working with here is x. X has to be greater than 0. We can't plug 0 into the natural log function to begin with, so we should be in good shape. And the idea is we want to start with something that's hard to integrate. This is hard, right? This is the integral that's hard. Well, I can't even write hard. Hard. And we're hoping that we wind up with an integral over here that is easier, or hopefully easy. And when we look here, we know how to integrate x squared, so we're in good shape. This is going to be a half of, we have the 1/3 x cubed natural log of x minus 1/3 times the antiderivative of x squared is just 1/3 x cubed. And then after this is all said and done, we'll need plus our constant of integration, because we're working with an indefinite integral. And if I factor a 1/3 out, I'm going to wind up with a 1/6 of x cubed natural log of x minus 1/3 x cubed. I could have factored out an x cubed as well, plus that constant of integration. So we might have chosen to factor the x cubed out here just because we can. It's not necessary to do that, but we did.